Calculate a double integral. I'll include the playlist with many more practice problems as well as the background information right here. I'll also make it clear at the end of the video what we've calculated here. Let's start from the inside and rewrite e to the power of 2x plus y. That is the integral from 0 to 1 of e to the power of x times e to the power of 2y. Exponent laws, so to speak, in reverse now. Powers with the same base are multiplied by adding the exponents. I just did that in reverse. So that for the integral with respect to y, we now have a constant factor here, e to the power of x. We can pull that out now. Then basically the integral from 0 to 1 of e to the power of x. And then here the integral from 0 to 1 of e to the power of 2e dy. I'll write dx here, I'll leave the outer part as it is for now, and basically the inner part. E to the power of 2i, its potential antiderivative is e to the power of 2i, and in front 1/2, so 1/2 times e to the power of 2e, is that correct? So, and all of that from 0 to 1. Insert the upper value -1, insert the lower value. Then we get e to the x, plug in 1, that's 1/2 times e squared minus, plug in 0, that's 1/2 times e to the 0 dx. Now we can pull out the 1/2 to the front, so we have 1/2 times. Integral from 0 to 1 e to the x, and then e squared minus e to the x, that's 1 minus e to the x dx. Now we can easily find an antiderivative of that. Then we have 1/2 and then e to the x times e squared. E squared is a constant factor, so the antiderivative is accordingly e squared, e to the x minus, and e to the x is clear, e to the x from 0 to 1. And then we can now substitute the upper value here accordingly, so 1/2 upper value. Substituted is e to the 1. So e squared times e to the 1 is e to the 3 minus e to the 1. E to the 1, and then minus 0 substituted. E to the 0 is 1 remains e squared, minus 0 substituted, minus 1. So, and you can calculate the whole thing. What do you get then? You get the volume, if we make that clear. I'll try to sketch it roughly. Yes. So we have the boundaries from 0 to 1 and 0 to 1. 0 to 1 and 0 to 1. So something like this. And then over this function, which seems roughly like this, I'll try it like this and like that. Well, roughly exactly. Yeah, if I go down here, dot, 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 go down here and here. Then here we have the body, whose volume we have determined accordingly. Everything else is in the playlist. So math vocabulary is recognized and danger avoided.